Hi everyone, so this is just a quick update video to share how I'm getting on with the motor control I'm developing. So now I've got yet another working prototype sitting on my desk here. It's connected up to this 36 volt chainsaw motor, which is running off a 5-cell battery. So I've kind of got the lid off it just now because I'm just still doing various tests, and I can say that so far it works. So we'll just spin it up for what it's worth. So yeah, that's pretty much all that I could show. It works, it spins the motor. So the next stage is to get this on a vehicle and probably test it almost, well, to the maximum current that whatever motor I'm using can take, because that's, unfortunately, that's an essential part of testing. We need to find out what this thing can take. Now, if this handles the 75 amps that I've designed it for, that's great. I'm not going to push it any further than that. My theory on it is, if I run this at 75 amps, as in I'm like powering some bike with this on a 12-cell battery and 75 amps are coming into the controller, obviously that means that more amps are usually coming out. Phase amps are usually more than the battery amps, apart from when the motor is like unloaded and running at full speed. So I reckon at 75 amps coming in, it's probably going to fail, but I may be pleasantly surprised. Of course, it will have pretty much all the features of a standard Vesc that you can buy, CAN bus and everything, but the only feature it's not going to have is the NRF module. I will make a connector external to the unit so that if anyone wanted to add on that, they could connect one up just to the connection. But I'm not going to supply the board with that. I'm just trying to keep costs down as much as possible. I think, unfortunately, this is going to be retailing for £90 a piece at the moment. I'm actually going to sell 3 of them, and I'm going to keep 2 for myself. And after that, I think my next iteration will be going onto the Xometry website so that I can design my own case for this, because these Hammond 1590B boxes are not ideal for this. I just don't like the shape pretty much, but it was pretty much all I could get. I'd like to design something a bit more versatile, but I think after I've designed this, the next thing I'll design is just a sort of generic Vesc board, just a rather large board on a heatsink which exposes every single pin on the main chip, so that you can like do whatever you want, connect whatever you want up to it, do scripting, basically use the full features that the hardware can support. And it'll just be some sort of development board that you can use for like running wind turbines or generators or whatever, which ties in with the inverter generator project that I'm doing. Do a test wind on this. 10 turns, see how much voltage it outputs when mounted on the generator, and then once my bigger wire arrives, I'm going to wind this properly with the thicker wire, and I'm going to connect a Vesc up to it, and then somehow program it to run a servo. I don't know if that's possible or not. We'll just have to find out. So very happy with the progress. I'm just going to keep testing this. If it's good, I'll make the rest of them and then just get them up for sale after I've registered my business and everything with HM Parliaments and Governments PLC, so that they can steal money off me when I start making a profit, if indeed I ever do.